Okay, today we're going to look at integrating more advanced expressions, and I'm going to begin with this function, and I'm going to do the derivative of it to begin with, f prime of x, and if I look at it I'm reminded that I would need to do the chain rule on this. So this multiplied by this, which is 1, the inside function to the 100th times the derivative of the inside, which is 2x. Okay, so that's doing the derivative with the chain rule. Now, because that's true, that would mean that if I were to write this in reverse form, the integral of this with respect to x must be the expression I began with. So the question I want to look at is, how do I go from this and know that it's going to be that? So this integration by substitution is the method we're going to use, and it is essentially the reversing of the chain rule. Okay, so let's look at this. Alright, so what you need to do is you need to think about what the inside function is, and we're going to call that u. And u is generally a part of the integrand whose derivative is another part of the integrand. So if I make u this, I know that the derivative of that is 2x. And what I'm going to do here is I'm going to isolate for dx, so I'm going to get du over 2x equals dx. And the whole idea is we're going to rewrite this expression involving u. So we've got the integral of u to the 100 times 2x times dx, which is du over 2x. Now you might wonder, why did I leave this 2x in? But you can probably see the answer. It's because those cancel out. And so we now got an integral of u to the 100th du, which is a basic integral. We can apply the integral power rule, which is u to the 101 over 101 plus the constant. Can then substitute what u is back into its spot, and you'll notice that that is what we began with on the last side. Okay, so your basic strategy with integration by substitution is that you need to rewrite the integral with respect to a different variable u that you can integrate. Okay, it takes a lot of practice to get competent with this. A lot of experience is needed so that you can properly pick u, because u is probably the most difficult thing to determine. Okay, so just in terms of steps, you would choose u, and how do you do that? You choose u as a portion of the integrand which is particularly prominent. That sounds kind of vague. Generally it would be so that that u, the derivative of that u, is another part of the integrand. That's not always possible, but that's a general guideline. Okay. You then take u off on the side and you do its differential or derivative. You isolate for dx and substitute and cancel so that your integral just has u's left in it. You integrate with respect to that, and then you replace everything with x. Replace all your u's with x to get back to what you started with. We're going to integrate. Let's start off with sine 3x dx. Okay. Well, because we have an inside function 3x, that's going to determine our u in this case. We're going to do du dx over here on the side. The derivative of that is 3. So du over 3 is dx. And then we're going to go back and we're going to replace with u. Sine u dx is du over 3. And because 1/3 is a constant, it can be brought out front. It's one of our properties of indefinite integration. And now we're down to doing an integral that's basic, that we know how to do. The integral of sine is negative cos. So it's negative 1/3 cosine u plus a constant. Replacing our u, we get negative 1/3 cosine 3x plus c. Alright, our next example, this is not a basic integral. meaning it's not one of the basic derivative formulas reversed. It's something much more complex, so it's an integration by substitution. We need to pick a u, preferably so that the derivative of u is another part of the integrand. So I'm going to choose this as u. Now that may not be apparently obvious at the moment, but let's work through this. So du with respect to x is going to be negative 10x. Alright, we're going to isolate for dx, so du over negative 10x is dx. I'm going to come back in here and do replacements. Okay, I'm going to leave the x above as it is. Dx is going to be du over negative 10x, and on the bottom I'm going to have the square root of u. Now you know if integration by substitution is working or not if you are only left with u's once you've done this replacement, and those x's cancel out and everything is with respect to u. So the question is, can you now integrate this expression? Well, if I bring out the negative 1/10 and if I write this root as u to the negative 1/2 du, I'm then into doing a simple power rule. Okay, so I raise the power by 1, I divide by the new power plus my constant. That's going to be negative 1/5 the square root of u plus c, and replacing my u back, I'm going to get negative 1/5 the square root of 4 minus 5x squared plus c. Okay, so again, finding the u is always the hardest part. You want to pick u generally so that its derivative is another part of the integrand. Alright, so if I make u x to the 4th, I'm going to get a derivative involving x cubed, and I'm hoping that it's going to cancel out that x cubed as another part of the integrand. So du over dx is 4x cubed, and so du over 4x cubed is dx. Let's go back and replace. I'm leaving the x cubed where it is because I'm expecting it to cancel out. I'm making this e to the u, and dx I'm replacing with this. Okay, my x cubes cancel out, and so I've got an expression entirely with u's. And I have a basic integral. Integral of e to the u is e to the u plus a constant, putting the u back in its spot results in my antiderivative. Alright, this example is similar to the second example I did. The difference is that if I were to pick u in a similar way to be this, the derivative of that would be negative 18x, and there's no x on the top to cancel out as there was in example 2. So this is some other type of integral, or perhaps it's one I just don't know how to do yet. Okay, so the question is, does it remind me of anything? Well, some of you might be thinking, well, it kind of looks like this one of these inverse trig derivatives, which is inverse sine u plus c. Okay, except that the u is a more complicated thing. I could think of this expression as 4 over the root of 1 minus something squared, and that something would be 3x. So let's let u equal 3x, which means the derivative of u with respect to x is 3, and du over 3 is dx. So if I substitute, I get a 4/3, which can be pulled out front. And this is now inverse sine of u. So this is 4/3 inverse sine of u, 3x plus c. The derivative of this would be my integrand.